Hello everyone, this is Sedi and welcome to Sedi's Mathverse. So the first video for today is all about divisibility rules, which is the tutorial number 10. Without further ado, let's get started. So the divisibility rule for 2 comprises all even numbers. Those numbers that end in the digits 0, 2, 4, 6, and 8. For example, 364 is divisible by 2 since it ends in 4. The same goes for 272, 866, but not for 961 since it doesn't end on an even number. All we have to do is to check the last digit and that's it. You will know if the number is divisible by 2. The same goes for the next 2. What are these numbers? But the divisibility rule for 5 states that all numbers divisible by 5 should end in 5 or 0. So another examining of digits rule. For example, 635 is divisible by 5 since it ends in 5. 720 is divisible by 5 since it ends in 0. But numbers like 234 or 1296 are not divisible by 5 since they end in a digit other than 5 or 0. The final rule, which simply checks the last digit of the number, is the divisibility rule for 10. All numbers that are divisible by 10 must end in 0. So for example, 690, 730, 1000, 2520 are numbers that are divisible by 10 since they end in 0. However, numbers such as 655, 925, 376, and 121 are numbers that are not divisible by 10 simply because they do not end in 0. Now, for the divisibility rule of 4, there will be an increase in the number of digits that we will expect. If the last 2 digits of a number is divisible by 4, then the number itself is divisible by 4. So for example, 576 is a number divisible by 4 because 76 is equal to 4 times 19, which implies that 76 is a number divisible by 4. Furthermore, 432 is also divisible by 4 since 32 equals 4 times 8, a number divisible by 4 as well. However, numbers like 322 are not divisible by 4 since 22 is not a multiple of 4. It's just 2 times 11 and no other multiple of 2 can make it suffice. And as well as 361 simply because it is an odd number. So if it is an odd number, it's not divisible by 2 and it cannot be divisible by 4 as well since in the first place, it is not an even number. So the divisibility rule for 8 states that if the last 3 digits is divisible by 8, then the number itself is divisible by 8. For instance, the numbers 4096 and 262,144 are divisible by 8. 096 is 96, which is equal to 8 times 12, which is indeed true. And 144 is equal to 8 times 80. This implies that these two numbers are divisible by 8. However, numbers like 1420 and 3004 are not divisible by 8. 420 is 4 times 105 and nothing else. And 4 is 4 times 1. Both of them are not multiples of 8, but they are multiples of 4. Now for the next rule, divisibility rule for 25. If the last 2 digits is divisible by 25, it can only happen if the last 2 digits are either of 0, 0, 25, 50, and 75. So there are only 4 of them. So numbers like 1,875, 3,050, and 6,225 are all multiples of 225 rather, because they end in these 4 digits. However, numbers like 335, 865 are multiples of 5 but not multiples of 25, simply because their last 2 digits are not either of one of these 4. Now, in this rule set, we will now consider the digital sum of the digits. And the first rule is for number 3. If the sum of the digits is divisible by 3, then the number itself is divisible by 3. Example is 684. 684's digital sum is 6 plus 8 plus 4 equals 8. The digital sum of 18 is 1 plus 8 equals 9, which we know is divisible by 3. Hence, 684 is divisible by 3. However, 521 has a digital sum of 5 plus 2 plus 1 equals 8, which is not divisible by 3. This means that 521 is not divisible by 3. Now, we have the divisibility rule for 9, but this is more strict than divisibility rule for 3 since it requires the number digital sum to be divisible by 9 and not just any multiple of 3. For example, 8,127 is divisible by 9 since its digital sum is 8 plus 1 plus 2 plus 7 equals 18, and 18's digital sum is 1 plus 8 equals 9. Thus, this is divisible by 9. However, numbers like 6,564 is not divisible by 9 because they can be divisible by 3. As we can see, its digit sum is 21, but 21 is not a multiple of 9. So this is not divisible by 9. Now, we will proceed with the rules wherein the last digit is omitted or the last few digits are omitted, and then they were multiplied by a certain number and then added to the remaining digits. And we begin with divisibility rule for 7. The sum of 5 times, I forgot to place it here. The last digit and the number formed by the remaining digits is divisible by 7. So, for example, we have 434. We will remove 4, then we will multiply 5 to it. 4 times 5 equals 20, and now we will add it to the remaining digits. 43 plus 20 equals 63. Then we will do the same job. Remove 3, then times 5 equals 15, then 6 plus 15 equals 21, which we know is a multiple of 7. We can actually stop with 63 if we know that it is 7 times 9. But I just showed you that it can be repeatable as long as we haven't arrived at a relatively small number yet. You can repeat the process over and over until you reach a number which you can easily deduce as a multiple of 7 or not. And now, we have the divisibility rule for 13. The sum of 4 times the last digit and the number formed by the remaining digits is divisible by 13. A given example is 533. We remove the last digit 3. Then, we multiply 4. 3 times 4 equals 12, and 53 plus 12 equals 65. 65 is 5 times 13, which means that 533 is divisible by 13. Now you can do this exercise. Prove that 936 is also a multiple of 13. Now, for the divisibility rule for 19, the sum of twice the last digit and the number formed by the remaining digits is divisible by 19. One example is 779. We omit the last digit 9, and then we multiply by 2. 9 times 2 equals 18, then 77 plus 18 equals 95. 95 is 5 times 19, which is clearly divisible by 19. So, we have proven that 779 is divisible by 19. An exercise for you to prove is prove that 988 is divisible or not divisible by 19. Now the divisibility rule for 23. The sum of 7 times the last digit and the number formed by the remaining digits is divisible by 23. One example is 345. We will omit the 5, so we will get 34, and 5 times 7 equals 35. Then 34 plus 35 equals 69, which is 3 times 20. And thus, we have proven that 345 is divisible by 23. Now, for an added exercise, prove that 420 is either divisible by 23 or not. Now, the divisibility rule for 29. The sum of 3 times the last digit and the number formed by the remaining digits is divisible by 29. So, one example that I can give is 899. We remove the 9, leaving 89, then 9 times 3 equals 27. 89 plus 27 equals 116. Then, I will remove the 6. 6 times 3 equals 18, and 11 plus 18 is 29. This means that 899 is divisible by 29. As an added exercise, prove that 1218 is divisible or not divisible by 29. And now, for the last number involved in this certain rule set, the sum of the last 2 digits and 4 times the number formed by the remaining digits is divisible by 16. So one good example is 4,830. We will remove the 32, and then we multiply 48 by 4. So we get to 192 plus 32, which gives us 224. Then 24 will be removed. Then we multiply 4 to 2, which is 8 plus 24 equals 32. A number we know that is equal to 2 times 16, a clear multiple of 16. Hence, 4,832 is divisible by 16. Now, given the same principle, prove that 6,576 is divisible by 16. Now, we are in the divisibility rules wherein instead of taking the sum of the last digits and the remaining digits, we will take the difference instead. So we will begin with 11. The difference between the last digit and the remaining digits is divisible by 11. One example would be 1,353. We remove the last digit, so we get 135 and 3, and subtracting it gives us 130. Then, 132, we will subtract it. We will subtract 2 to it, so to 13, so we get 11, which means that 1,353 is indeed divisible by 11. Now, to prove 2,000 321 is divisible by 11. Now, the divisibility rule for 17 is the same as 11, but the factor for the last digit to be multiplied is 5. So, one example that we have is 697. We remove the 7, then multiply it by 5. So, 7 times 5 equals 35. 69 minus 35 equals 34, which we know is 2 times 70. This means that 697 is divisible by 70. Now, for the divisibility rule for 27, the factor to be multiplied on the last digit is 8. An example would be 864. The last digit is 4, so we remove it and then we multiply 8 to that number. So 4 times 8 equals 32. 86 minus 32 equals 54, which we know is 2 times 27. This means that 27 is a multiple of 864. Now, we will state the rules for the other composite numbers that haven't been mentioned on this divisibility rule video. So we have 6 must be divisible by both 2 and 3, which are both discussed earlier. Then the same goes for 12, which has to be divisible by 3 and 4, which both methods are discussed earlier. 14 divisible by 2 and 7, 15 divisible by 3 and 5, 18 divisible by 2 and 9, and 20 divisible by 45. Now, for 21 to 30, we have 21 should be divisible by both 3 and 7, 22 must be divisible by 2 and 11, for 24, the number must be divisible by both 3 and 8, 26, the number must be divisible by both 2 and 13, for 28, it must be divisible by both 4 and 7. And lastly, 30 should be divisible by 3 and 10. So those are the divisibility rules for the other composite numbers from 2 to 30 that we haven't been discussed yet. Remember that if we memorize the first 4 rule sets, we are good to go with these remaining 12 composite numbers or even larger numbers. Now, here is a bonus question, and anyone who gets it right first in the comment section will win a surprise prize. So here's our bonus question. What is the smallest positive integer that is divisible by all numbers from 2 to 16 inclusive? Comment your answers down below, guys, and who knows, you might be the lucky winner of today's prize. That is it for today's video, ka-Mathverse. I hope you learned something and enjoyed this video. If you did, subscribe to our official YouTube channel and follow our social media accounts whose links are shown here. That is it, guys, and remember that mathematics is incomplete without you, and chase your greatest moonbeams. Till next time.